Morning, James from Elite. So I'm going to a property near Lincoln. Customers rang in. They are having not great bills at the moment, £10 a day for their heat pump, Daikin heat pump system. So they've asked us, Elite and us as heat geeks, to go down, take a look, see what maybe is wrong, some settings, do a full heat loss report as well, to see if the heat pump's the right size, the heat pump's the right size, the radiator's the right size, the pipe right size, everything as a system is right, and see what's going on really, because the bills are fantastic. I personally think, even before going, that it's potentially just controls, but we say we're going to do a full report. There has been situations where the heat pump is low refrigerant as well. So if there's nothing untoward on the controls, on the report side of things, the heat loss report side of things, if the SCOP and the COP is very low and everything seems right, I would get our F-gas trained engineers to go and weigh the gas and see if there's enough gas in the monoblock unit straight from manufacturing, because we have had a few issues with that in the past, especially when it came to the depth of winter. The units was struggling to do the defrost cycle, and it was just lack of F-gas in the unit when it came out. So that doesn't happen that often, one or two out of hundreds and hundreds, but can happen. We're qualified to do the F-gas side of things, but yeah, it's quite a good part of my job really, not to rip into any other engineers and their work. We've all had our learning curve, but it's to, make the heat pump better, the system better, and yeah, put a smile on the customer's face and get them bills down. So take you to the property and we'll go through it together. All right. Well, this is very nice. I've just been through a gated community on the quayside. It's beautiful. Lovely, lovely, lovely. All new builds. So it's not like it's going to be a leaky home. So that's going to be interesting. See how we get on. Okay, so I've got to the property. The property is about 20 years old. They've got a couple of extensions which are new build. So we're doing the heat loss survey for that. The first thing I've noticed about the heat pump is it's only 200mm away from the back of the wall. So it could be done with probably another 100mm off the wall for nice air circulation. There is a wall at this side, but it's probably a good 3 meters away, so I won't be too worried about that. Other than that, it looks okay. It's in 28mm pipe going through to the cylinder, really close to the heat pump, to the cylinder, which is all right. It does need a bit of a clean. The evaporator needs a clean at the back, bit of TLC. Condensate straight to this slab, so really they could have done with putting a drip tray underneath it and running it into the stone at the back, or just making this a solid stone base as well, so the condensate would drip into the water table that way. At the moment it could maybe become a slip hazard in the winter. What the customers described to me is the bills at the moment are about £10 a day, which is not great in the summer, and they are up to about £30 a day in the winter. Checked the inside, and there's lots of, I can show you inside of what we can improve and what the original installer's done wrong, and it's not great, but we can improve it. So let's take you inside. Okay, so what I've discovered in this cylinder covered plant room area in the garage is quite noticeable. The first thing is no lagging on the pipes. And now how bad this is that there's no lagging on the pipes, and therefore it started to create a bit of damp in this garage area when it's particularly cold. So the customers put a dehumidifier on in the room, Obviously it's not needed so much in the summer, but in the winter they've been putting that dehumidifier on. We've just done a quick calculation. It was using about 7 kilowatts a day just by putting that dehumidifier on, trying to cope with the damp in the room. And it's probably because there's no lagging on the pipes and it's going to a very, very cold garage area. There's no heating in this area. So yeah, that's not great. Other things that we've noticed is that there is a pump on the heating circuit there and a pump on the underfloor. Now, we could probably get away with them putting the pump on the underfloor side of things because it's kind of hydraulically separated from the pump in the outdoor unit, but that one isn't up there. I'm very surprised that the Daikin unit hasn't come up with a fault code, a flow fault, because pump on pump it normally brings that up, but that's not going to help things. That's going to confuse the pump outside, maybe speed it up when it doesn't need to and modulate down when it's supposed to be gaining more. I've pulled out the basket filter and it's absolutely full to the brim. So when they're doing the hot water now in the middle of the summer, the flow rates are terrible, really terrible, and obviously not getting them kilowatts out of the unit to put into the cylinder and getting that hot water cycle over as quick as possible. So back to the heating. It's a combination of bad errors and bad installation and bad setting up on the controls. For some reason, I'm not a tiling expert, for some reason the tiler said that the floor can't get up over 30 degrees. Might be the case, but that's surface temperature, not water pipe temperature, so they've told the customer not to put it over 35 degrees on the underfloor. We don't need to go over 35 degrees on the floor anyways, but I just don't really know why they've said that. But what they've done is they've set the weather curve to 50 degrees at -2, but then throttled it down on the underfloor. So when that is raging out at 50 degrees in December, which they've had really high bills, that's getting mixed back down and going back to the heat pump really quickly and turning the heat pump back off because it's not having to go, it's not being allowed to go into the underfloor. So that just makes the heat pump cycle on and off and on and off, which is not good. That's not really great. The bigger problem, when I first originally came here, I thought this was piped as a water volumizer. Don't know what this is piped as. So it comes off the heating flow. It tees off the heating flow and then goes into this and then comes back on the return and goes back out. It's literally acting like a radiator or an underfloor or anything. It's just teed into the heating circuit for no apparent reason whatsoever. It's supposed to be a water volumizer to take care of the defrost cycles, so it doesn't grab it from the radiator and the underfloor. But they've literally just teed it off, coming into there, going back out on the return, and going back into the common returns of the heating, of the underfloor. Teeing back in and going back to the heat pump. So this is a huge problem. They're heating this for no reason. This will heat up really quickly and go back to the heat pump as well and turn the heat pump off quicker because it's not getting pushed into the house and absorbed by the house. It's just going around this. This is really well insulated, going back to the heat pump, turning that on and off even quicker. So the setting up is really high. It's not allowed to go back into the house because of the underfloor and because of this. So it's just cycling all the time. So what we need to do is turn this into a volumizer, take these pumps out of the equation, take them out of the equation, then these zone valves, and put it into a one zone system because it's not got loads of different insulation values in the house, no big wings, not massive solar gain, and I think we can put it into a one zone system. So just on its surface, we've been here an hour now, that's what I've come up with so far. The heat pump outside is a 14 kilowatt. They do about 11 kilowatts at -2. I think it's slightly oversized, but obviously they've got it now. Unfortunately, I don't think they're going to swap it. We just need to set this up the most efficient way it can be. Hot water controls. What we found so far is that they've put it on a schedule and reheat, but it's just there's no schedule in there. And it's topping itself back up at 40 degrees.
There's only 2 people in the house. It's a massive cylinder, so once the drop off's quite quick, every shower is just it's coming back on and coming back on all the time. That will take it away from the heating in the heating season and make the house even colder. So we can allow it to drop more because of the occupancy, and also the customer hasn't been shown how to lower that hot water temperature, because they've never run out of hot water. They can start to lower it and see exactly how much they need in the tank of hot water. They have a disinfection cycle there on a Sunday to take care of Legionella, so that's not a problem, but it's just on too much too quickly, and obviously too much hot water if they don't need it, so that can be sorted out as well. So lots of what we can get at, which is good, because obviously they've got big problems. You would like to see a lot of problems. If they're big problems with their bills and nothing to get at, you'd be scratching your head a little bit. So yeah, basket straight away, that'd help flow rates on the hot water, and they can start trimming down the usage. And then the heating side, we're going to do a full heat loss report and see what that comes up with as well. But this needs to be a bit of a revamp. So yeah, see how we get on. I hate these bloody clip things. Whoever invented these. Oh, I've done it straight away. Not so bad. Okay, so a few things that we can set up on this Daikin controller is tank. It's on schedule and reheat for 0 reason. They haven't got solar or time of use tariff, so there's no real need to do a schedule. So we're going to do heat up mode is reheat only, and then we're going to do the hysteresis. 27 degrees, we don't want that. We're going to do about 12, and the maximum, there's only 2 of them, 50. Disinfection I'm happy with, and then we can put that to 48 and they can start doing that down, tailing that down. The one thing that this isn't so bad, because backup heater, normally the backup heater is set at 0 degrees, so that backup heater comes on at 0 degrees. They've set this to -3, which is fine. It'll probably 1 or 2 times a year come on, but we don't need that to come on at all. It's a 20-year-old house. I'm going to put that to -7. Booster heater is allowed just for the disinfection, and our main problems are the weather curve is at 50. This is new build house with mostly underfloor, so I'm going to do that at 35. I'm going for it to 25, and it's the starting temperature before was 12. Oh my god, should be 20. So that's a nice care throughout the heating season. Emitter type underfloor, because we want the delta T to be 5, which it is, which is good. We're going to put a Madoka thermostat on here. They've only got third party on and off controls, which is not great. So we can put a Madoka thermostat on here, or we can run it as pure weather compensation. I still might be able to put the LAN adapter card in the side here to get them on the Enecta app. What else can we see? There was some, that's a problem. So if you read the manufacturer instructions, this is the increase around the weather curve. That increases 2 degrees over a span of 4 degrees. So, and that around 0. So that's going 2 degrees over +2 or -2. So it's going even higher at that, even higher, not on top of 50 degrees, but obviously there should be no increase at all. See how quick, easily though you can accidentally put them on. Overshoot 4.
So it's overshooting 4 degrees over its target temperature as well. That should be, they should have a 0 on that. But yeah, 1. Them 2 things are even on a higher weather curve. They're overshooting on the curve and on the target flow temperature as well. Crikey. Back to tank, just double check. Reheat, disinfection, yes. Maximum 50. Hysteresis 12, just because there's not that many occupants for the size of the cylinder. Margin 2, that's preset at 2 on the... we can't really do much with space heating and cooling because... I don't know why they even changed that sampling. The rest looks okay, but then that's being important is that overshooting on the weather curve and the flow temperatures, that's going to massively hurt efficiency. That basket filter, by the way, I'll bring you in here, that basket filter, that's not being over breakdown of radiators or just general dirt over the heating season. That was plumbing paste on that, so that's been from day 1 and never clean from day 1. So they've had bad flow rates throughout the installation, which has not been good at all. They've had other people here to check the work, and even they didn't pick up on that. So yeah, from day 1, it's been set up really bad, plumbed not great, and they've even had bad flow rates on that. So say lots to get into and lots that can improve and get the faith back in the heat pumps, because they're not the problem, the bad installers are. Okay, I think we'll start the heat loss survey now and see what that throws up. So it's 14 kilowatt outside. I reckon this house is about 8 or 9 kilowatts at best. Can't really do much about that. It's not going to be massively problematic on the efficiencies. The heat pump modulates down to 30% of its capacity. So it's just going to start cycling a little bit quicker in them warmer temperatures, 12, 13 degrees. Whereas the right size heat pump would not cycle as much throughout the year. So that's what comes with an oversized heat pump. But we'll do the heat loss survey. I could be wrong. See how we get on and see what the results show you there. But yeah, I think that's around about here. I could start disconnecting these pumps and these zone valves now, but the heating season's not even on. We'll just take them out and lag it up. That would be the best thing to do. So yeah, okay, onto the heat loss survey. Okay, so I've finished my heat loss survey for the property. We'll see what that brings. It's a 14 kilowatt outside, but they deliver about 11 kilowatts at -2. I don't think it's that big, but it's in now, so can't do really too much about that. The major problems with the heating system was the weather curve was really too high. Set all really wrong, too high. They tried to plumb a volumizer in, but it just acted like a radiator off the heating circuit. So what it did was go straight to that buffer of water in the garage and heat up, and then go straight back to the return. So it was turning the heat pump off quicker because the flow temperatures was satisfied. And then never get into the underfloor and the radiators, and that's why the customers called and had high bills, turning the heat pump on and off, and the efficiency, the SCOP of the machine this year was 2.6, so 260% efficient. I think we can get that to 350% efficiency, hopefully 400, with the upgrades that we can do. What else was it? There was lagging, that wasn't great, there was no lagging on there. We need to take out the pumps, we need to take out the zone valves, we need to put it into a 1-zone system, and yeah, just strip it back to bare basics. Get the Madoka thermostat on there, set the weather curve right, and see how they get on from there. But there's huge improvements we can make.
I will do another video after the heat loss survey. We'll go through that, and then we'll see what anomalies that might bring up as well. So yeah, it's just all part and parcel of this project today, and saving the customers some bills. So I think what we've done today is going to be a big help. We've tailored their tank temperature as well. It was quite hot and coming on a lot quicker than it needed to. The hysteresis was quite small, so we put that to 12 because there's only 2 occupancy and it's a big tank, so it doesn't need to come on that often. And I've showed the customers how to lower the tank temperature, knowing that the disinfection's on a Friday at 8 o'clock on a night just before bath time, so I'll have that disinfection cycle to blast off any Legionella possibilities. So that's that. So yeah, there's easily a dozen fixes that I've brought up on there. So yeah, lots of improvements, and yeah, should be good. We'll see what the heat loss brings up. Okay, so I finished the heat loss report on the property we went out and saw today in Lincoln. Threw up well, surprises from what they installed, not surprises to us, but yeah, so the heat loss came out at 8.47. They actually installed 14 kilowatt. Now, it's not actually 14 kilowatt at -3, it's around about 11 kilowatts at -3 it can perform at. So I would have installed a 9 kilowatt that can do 9 kilowatts at the design temperature. So they have overspec the heat pump quite a bit. Not going to make massive differences, but still it's not great. As I say, a heat pump's compressor can only modulate down to 30% of its capacity. So it's just going to start cycling quicker. Probably start cycling at maybe 10 degrees instead of 13, 14 degrees. So along with the heat pump, and that's the heat pump 8.4 at -3, as you can see. And with that, the underspec the radiators. the radiators will work at 50-degree flow temperature, like that explained on the weather curve setup. But ideally, we want to match the potential of that underfloor downstairs. That can run at 35 degrees at -3, and we want to fit the radiators the same as the underfloor, so the whole house can be one flow temperature. So they've fitted the radiators for 50 degrees, they've set it at 50-degree flow, and then they've mixed it down at the underfloor. What that's going to do is it's going to send it back to the heat pump quicker, satisfy that heat pump, and think it's done its job, and just turn off and start cycling just a lot more. So that's not good. The heat pump was at 260% efficiency. We could easily get that to 350. I would leave the radiators as they are at the moment, see how it does perform in real world scenario. Realistically, they might have to upgrade at a later time. But yeah, I mean, overall, some of the factors are that let's have a look. It wasn't piped correct at all. Therefore, that dehumidifier had to be turned on to just get the moisture out of the room, which is crazy. Heat pump was not far enough up the wall. No magnetic filter. Basket filter wasn't cleaned since day one. Volumizer was piped as a bypass. Weather curve was set up correctly, amongst other things, on the controller. Radiators undersized, heat pump oversized. Not showing the customer how to reduce the flow temperature and the store temperature of the tank as well. They didn't put a Madoka thermostat in, which is, is a must if you're in, the manufacturer's controller with the manufacturer's heat pump. But I can put that aside. Things can go wrong with the heat pumps. They can be installed incorrectly as you're learning about new heat pumps and installing them. But you're supposed to go back, correct what you've done wrong, learn from your mistakes, and go forward. And that's how you learn and get better at your job. So, and that's how we've learned, over the last 10 years doing a heat pump. So, yeah, not the worst one I've seen, but definitely not the best. So the next thing I'm going to do is complete the heat pump report, send it off with my report to the customer, and then give them a quotation to just rectify the problems. Not going to be massive, just because it's all in that plant room area, and see how they're getting over the year, and go back, and I'll probably have an update after that. So yeah, hopefully you've enjoyed this the video. I haven't slated the other installers too much, I hope. So it's all about learning and going back and improving. If you like these videos, please subscribe to our YouTube channel, get more likes and more views. And yeah, thanks for watching. And if you need any heat pumps installing, take a look at Elite.